looking at the first problem. So we have the tangent of theta minus 3 cotangent of theta equals 0. And what I always do first is I just graph it. I want to see what it looks like. I have no really idea. I know this is going to have some asymptotes in it. There's going to be weird ones, but I still want to see what it looks like. So I bring it over to my calculator or whatever, and I graph, and I can see, okay, I'm going to have this solution. This is going to be my first one, and this is going to repeat every pi because of the period of this function, and I'm going to have another solution, and it's going to be occurring every pi. And so I have an idea of what's happening, and so let's go see what it looks like algebraically. When I'm looking at this problem, I'm thinking, man, I can't, if I have this subtraction inside here, I can't set these equal to each other. That's not going to help me. When I had this with x's, I would try to factor something to get it equal to 0, or I don't know. I don't know where to start, but I know that I can put it in sines and cosines. That's something I can actually do. So I rewrite the tangent, I rewrite the cotangent, I find a common denominator. I go ahead and do this a little bit earlier. I multiply the denominator by 0 so that it equals 0. Anything times 0 is 0. So this is, now I'm just working with the numerator. And they do something very clever here. They say negative 3 cosine squared of theta could be written as cosine squared of theta minus 4 cosine squared of theta. That is true, right? That gives you negative 3 cosine squared theta. Why do they want to do this? Because I have sine squared theta plus cosine squared theta equals 1. It's pretty helpful because now I can just move the 1 over, divide by 4, and I end up with a cosine of theta equals positive and negative half. All right, so here's positive half, right, is pi over 3, and if I add pi to that, I'm at 4 pi over 3, and remember the cosine is the inverse cosine is occurring here, so if I have negative half is 2 pi over 3, and then when I go add pi to that, I'm at 5 pi over 3. And we can also put this function in, 1 minus 4 cosine squared of theta, back in our graph to see, do we get the same solutions? And yes, we get the same solutions. So it's a pretty interesting question. And you were asking about the k's. How do I know the k's? Well, the graph also helps you a lot with that. We're trying to say, we want to represent this solution, this solution, this solution on for infinity. So if k is 0, let's look at the solution here as they wrote it. If k is 0 here, then 0 times pi is 0. So that gives me the pi over 3 solution. If k is 1, that means that this is pi, so pi over 3 plus pi. If k is 2, that's 2 pi, so that keeps moving us out on that graph. So looking at the graph, you're like, how do I have a fixed rule for k? It is the period, it is how often the function is repeating itself, but you can also see it when you look at the graph. So I hope that helps you with the first one, and then I'll make something for the second question you had too.